Hello, everybody. Welcome back to science class. Another week, another lesson. We're kind of forging ahead. We're moving on. You guys probably heard this week that the governor canceled school for the rest of the year. That really sucks. And I think even though we kind of all knew that was probably going to happen, it's no fun to actually be here knowing that we're not coming back this year. And we're not going to get that closure for the end of the year and everything that we have planned to do in school at the end of the year. So I just want to invite you guys to come back next year when you're all in high school. Don't forget about us. Swing by Bryant sometime. Maybe spend some of your volunteer hours. I know a lot of students have to do that. Come back and help out at Bryant. We'd love to see you again. We don't want this to be, how we end things. Ugh. So anyway, last week you guys got a chance to take the quiz of our unit. How does a tiny seed turn into a massive tree? A lot of you did really well. A lot of us did it. I'm not sure how much we studied for it, and a lot of us didn't even log in to do it. I appreciate your guys' feedback on my little survey last week about how you're doing, how remote learning is going. And I think from the responses I got from that and talking to other teachers, both at Bryant and even not at Bryant, we're all in really different places with this remote learning thing. Some of us really like it. We like working through it at our own pace, and we are self-motivated and we can get it done, and we're begging for more work. Some of us have a hard time getting to work from the comfort of our own home, or maybe it's not that comfortable at home, or maybe we're sharing computers with people, or maybe we're responsible for different things. And I just want to tell you guys again, we get it. We're being pretty flexible with grading. So as long as you're getting on and engaging with the content and working on stuff, you're going to be just fine. Okay, don't stress out about it. If you're here and you're listening to this video, you're doing it. You're doing a great job. So thank you, and keep it up. At the end of the last unit, we were talking about the carbon cycle and how carbon goes from place to place around the world. One of the places carbon ends up, especially since we've been digging it out of the ground in form of fossil fuels and burning it to create energy that we use in our houses and that we use in our cars, a lot of it's ending up in carbon dioxide in the atmosphere. And this is causing an effect that was already here called the greenhouse effect to sort of amplify. So our goal for this week is to figure out what is the greenhouse effect, how does it work, what does carbon dioxide have to do with it, and why should I care? Okay, so below this video, you will see this video here called Climate Change, Earth's Giant Game of Tetris. I kind of like going through YouTube and finding all the different videos about these concepts. There's a bunch of really good ones. I think this is the best one, and it's going to best blend our learning that we did in the last unit about carbon dioxide and photosynthesis, and help us sort of bridge that gap as we move into the greenhouse effect and climate change, which is what we're moving into. But there are also these 3 other really great videos. I want to just post them anyway. You don't have to watch these. If you do, you'll learn more. You'll get a better idea of the greenhouse effect and how to think about it. So if you have the time, go ahead and watch those. If not, let's move on. I just want to give a quick primer on what is the greenhouse effect. So here we are. I'm going to exit out of my picture. We have the sun. The sun gives off energy in the form of, well, lots of different types of form, but like UV radiation, visible light, and really the difference between the types of energy that things give off is wavelength. So the type of energy that the sun gives off is kind of a smaller wavelength. It comes down, it can make its way through the atmosphere, no problem, and it hits the Earth. Once energy hits the Earth, it can either be absorbed by the Earth. The ocean absorbs a lot of heat. It can be reflected off like the ice caps. They're really white and bright, and they kind of just reflect the waves back up into outer space. Or if it's reaching land or something, the land warms up and then it radiates heat back off in a long wave radiation. This is kind of like if you put your hand over the stove. Okay, you're not actually sticking your hand on the stove or sticking in fire. We learned about this. This is radiation. It's just kind of giving off heat. And when the sun warms up the earth just gives off heat, okay, in the form of long radiation. This type of long wave radiation can be absorbed by particles in the atmosphere, whether it's carbon dioxide, CO2, water, H2O, or methane, CH4, and there's a few others. But these can just kind of jiggle these molecules. When the heat hits these molecules, they kind of jiggle back and forth, and then they re-radiate that heat all around them, some of it up, some of it back down. If these things weren't there, then the heat coming off of the Earth would just slowly make its way back up into outer space. But because these things are here, they can capture that energy and re-emit it, some of it, back down to Earth. Okay, so again, this is kind of a good thing. If we didn't have any atmosphere, Earth would pretty much be inhabitable, and we wouldn't be able to survive here. But there is such thing as too much of a good thing. So if we have too many of these things in the atmosphere, it's sending too much heat back down to Earth and keeping it in our atmosphere. And this is what's causing climate change or global warming, which we'll get into starting next week. But this is the main effect which causes that. They call it the greenhouse effect because, well, this is an example of a greenhouse. It's basically the same thing. Sun's energy can go through this glass pretty nicely, but then when it gets re-emitted back up, it bounces off the glass. And we can kind of think of the atmosphere around the Earth like the glass in a greenhouse. Okay, too much gases in the atmosphere, not much of the heat's going to escape. Too little and too much is going to escape. So you can have this greenhouse in a pretty cold environment, and as long as it's sunny outside, it's nice and warm in a greenhouse. That's why we call it the greenhouse effect. We are using a new website this week. Here are instructions for how to log in to that website. So steps 1 through 6. Step 1, go to explorelearning.com. You have never been here before. So what you need to do is click login or enroll. I have my username and password here because I've already logged in, but you need to enter your class code here. What's your class code? Depends on when you had me for science. First, third, fifth, or seventh period. So whatever you are, I'm just going to use this one for example. Enter it in here. All right, so you've registered for my class, period, whatever, science. You don't have an account, so click on the green one that says I need to create an account. You'll enter your information. Okay, first name is Mr. Last name is Good. Don't worry about the email address. Username, use your school ID, whatever it is. That's just so you don't forget your information. And then your password, whatever your school password is, enter that here. All right, and once you log in, you're good to go. This is a website where you can play around with science simulations. So if you're looking for some extra science to work on, just kind of browse through this website. There are a lot of really cool simulations you can try and concepts you can learn about. But of course, the one this week is called the greenhouse effect. And this is the simulation we'll be playing around with this week. So basically, this week, it's kind of in a quiz form, but it's more just work your way through these instructions. Starting with question 1. What do you notice when you get into a car that has been sitting in the sun for a while? Just put your answer there. You don't need a simulation for that. Same with question 2. Why is the inside of the car so hot? Just put your answer there. Then we're going to be getting into step-by-step how to use this simulation and answering questions about some results that you see from the simulation when you're going through it and adjusting some of the knobs. So greenhouse effect and greenhouse gases are generally a good thing, but too much of them is where the problem comes in, and that's what we're learning about this week. So for this first one, it says, in your simulation, set the greenhouse gases to 0% and the simulation speed to fast. So you'll kind of be going back and forth between the instructions here in Canvas and then over to your next tab where you've logged in and you can adjust the simulation. So again, greenhouse gases to 0, simulation speed to fast. And you can just kind of control the knobs here like this. And I'm going to hit play. Night, day, night, day. So it's going pretty fast. And we're actually collecting data as this happens. You can click on the actual numbers. This is your data table. The bar chart, or the graph. And some of the questions are going to be asking specifically about one or some of these things. So to toggle between them, you just click on the tabs here. Okay, that's pretty much it. Go through here, follow the instructions, type in your answers. There are a few multiple choice questions, but most are just type in your answers to, because I want to see what you're thinking about the simulation. So when you're done with these questions, you are done with the activity for this week. That is it. Let's see. I don't know how to get my camera back, so sorry. Anyway, that's it for this week. If you have any questions, again, always feel free to text me, email me, call me, whatever, inbox me right here on Canvas. Good luck. The weather's going to be really nice this week, so I think you guys should get outside and enjoy the weather a little bit. Okay, it's really good for, oh, there I am. Hi. It's really good for our mental health to get outside. I've been taking so many walks. It's actually been pretty nice the last couple days. Let me know if you need anything. See ya.